So in this activity, we are changing the parameters a, b, and c, and this is standard form of a quadratic function. This is what a quadratic function looks like in standard form. Do you know any other forms of quadratic functions? Have you ever heard of them? Any others? There's three. What does a quadratic function look like? What does it look like? Name a shape that it looks like. Thank you. Every time I ask you that, please say it looks like a U. That's all I want to hear you say. It's shaped like a U. Okay? It's not is it a straight line? Okay. So what we did was we filled in this chart, we changed the parameters, right? What happens when A is less than 1? Or should I say negative? What happens when A is negative? All right. Flips upside down, right? Which it looks like a mountain. What does this look like? In terms of like, what's the opposite of a mountain? A valley. And then what happens when the A value is in between 0 and 1? Do you remember? What happened when we made, let me go back to 0. No, 0. And this was 0. So what happened when I made A between 0 and 1? Look at it. What's happening? Okay. All right. I'll take that. I'll take that. So we just wanted to review that. And then we were talking about what changes happen, what's the y-intercept, stuff like that. All right. So now we're back to this chart. No, sorry, this one. Okay. So I'm on 2.1. Okay. Okay. What does V stand for? What does V stand for? What does V stand for? V. I'm pointing at V. It stands for the vertex. So when you change these, whatever it tells you to change them to, you need to write down the vertex, right? And you need to write down what you changed A and B to, okay? Did we do this already? So do you need my help with this, or can you click the buttons yourself? So this one is 2x squared, right? Plus x. So that means I need to change the A to a 2 and then the B to a 1. All right. So now it looks just like this one, except we don't write 1 over here. They should have done that, but they didn't. Okay. Right. Okay. So what's the vertex? What's the vertex? So write the vertex down and then write down what A is and what B is. A is 2, B is 1. Okay. And then you're going to just hit the subtraction. So you're just going to subtract 1 for this one. Do you know what to do?
Do I sound smart?
Yes, you are smart. I'm trying to tell people, like, do you understand that we really haven't done algebra 2 until now? Like the sequences, I don't know what that was. But polynomials is where algebra 2 should start. So he just said, oh, it's starting to get a little harder. Yeah, because we're really doing algebra 2 now. Just saying. I know. Like most of what we've done, I'm reviewing algebra 1. Okay. Are we finished with 2.1? Okay. So have we answered the questions on the paper? Does anybody need help seeing what the paper is telling you to do? Oh, good. You say you're done with the whole chart? Oh, look at you. All right. So can you answer the question? Based on the information from the table, check question 7 to see if the rule you wrote is correct. Didn't I give you the rule? Using the information from the table, write a rule to determine the x coordinate. I think I gave that to you, didn't I? Didn't I give you 7? Yeah, if I gave it to you, then it means it was correct. So predict the x value of the vertex of the parabola 3x squared minus 6x. So this one was 2x squared plus 4x. Let me go to 2x squared plus 4x. So the vertex is -1, -2. And so what was it when it was 3? Or no. Minus. Okay, minus. So, okay, so it's -b over 2a, right? So to find the vertex, it's -b over 2a, right? So it would be negative, this would be negative of a -4, or sorry, that's +4. And then 2 times 2, right? Do you see that? And that's how I get the number 1. And you see the 1 right here? Hello. I want you to use this to calculate the x value of the vertex. So if it's 3 and 6, or sorry, 3 and -6, what do I put in this formula? What's the b? So if it's negative of a negative, that means it's positive, right? Yeah. So it's just 6 divided by 2 times what? What's a? 3. So 2 times 3 is, so 6 divided by 6 is, so it's also 1, right? That's my x. Then if I take number 1 and I plug it into the x value here, it would be 3 times 1, right? Minus 6 times 1. What does that equal to? What's 3 minus 6? 30, right? So that's what you're trying to get you to see, that the prediction. Do you even understand what I did? If you don't, ask me, please, because I'm writing with a mouse and like it's ugly. I'm not writing in order or anything. It's just like all over the place. Okay. So to find the x value, there's a formula, which is x equals -b over 2a. If you look at number 7, it's there. It should be there. And you just take the a value and the b value and you plug it into that. You get x, and then whatever you get, you plug it back into the function and you get the y value. All right, that's my little summary. Oh, I hope y'all still weren't writing because I just erased that. Okay, explain how to determine the y value of the vertex. I just told you. So now somebody tell it back to me. Plug it back into. What do I plug it back into? Just say function. The original function, right? So the original function is the original function is right here. Okay. In this question, it was here. So the way that you technically would write this, let me see if I can write it with my finger, is f of, what was the number that I got? What did I get? I got 1, right? Yeah. So f of 1, and then you plug it back into the, whatever the function was. So all that, sorry, that's an x. Sorry. It's an ugly x, but you just take the number. That's what it means when we start like to insert things into a function. Input, output, always think like that, right? It's an XY table. But when we get to algebra 2 and above, we use function notation. We don't use y equals anymore, okay? Okay, so explain how to determine the y value. We substitute or we plug in the x value that we obtained from -b over 2a, okay? The axis of symmetry is super easy because the axis of symmetry is just the x value. So whatever you get for x is the axis of symmetry. So for this one, it would be x equals 1, right? Didn't we get 1 for both? For whatever over here and this one? So we're just going to say, did you get 1 for the vertex for every single one? Like, is your vertex? No, it wasn't. It was decimals. It was decimals. So it wasn't one for every single one. But it says the axis of symmetry is the line about which a parabola can be reflected without changing position. All that means is that it cuts it in half. Okay? All it does, the axis of symmetry, let me show you what does most because it's a little easier to see. Okay, so what was the function? F of x equals 3x squared minus 6x, right? So the axis of symmetry, you see that it was 1 comma -3, the vertex, right? So the axis of symmetry is x equals 1. So do you see how it cuts it in half? Can everybody see that? You see how it is you can fold it one way or the other, and it's a mirror image, right? So that's the axis of symmetry. So all it is the x value here. That's it. So can you please write that down somewhere? That the axis of symmetry is just the x value. The axis of symmetry, because number 10 is asking about the axis of symmetry. So underline axis of symmetry and then give yourself a note that the axis of symmetry is all it is the x value of the vertex. Okay. And you could also say it's the point x equals -b. Okay. Write that too. You see that up there? It's also x equals -b over 2a. That's 10. And that's for quadratic functions though. Okay. Okay. It says 11, write the equations in standard form for the two parabolas that have the same axis of symmetry but different values of a. Okay, this is what I'm gonna suggest. Can everybody get Desmos on their phone? Just graph two functions. Hold on. With no x part, just like, I don't know. Graph that one. Where is it? It's all the way up here. So no, it's all the way down here. So, and then do one that looks just like it, just change the number in front of x squared. Okay. And if you don't have the app, you can go to your browser. So you can go to Chrome and just type in DESMOS. Okay. So if you have Chrome on your phone or Safari, doesn't matter. It's going to take you there. So graph that one, or you can even change that one but just make it look similar. And then all you do is change the number. So make another one and just change the number in front of x squared. And then write it down on your paper, both of them. Do you have two functions? And you should be able to see what the axis of symmetry is. What is this axis of symmetry here? So you can copy mine, but make up another one that looks, change the number in front of x squared. That's it. Change the number in front of x squared. Write down both of them. And then can you tell me what the axis of symmetry is here? Yep, that's right. It's x equals 0. Now for 12, I want you to Google 12. You should be able to find the answer to that on Google. Number 12, Google it. Want you do number 12. And then tell me what you found. Tell me what it said. Yep, that's right. Okay, does the value of C, did we answer that? Does the value of C have an effect on this graph? We're on 13, right? Does the value of C have an effect on X? Okay, what value does C have on this graph screen? What value is C? What is it over here? On X. On X. I mean, no effect on X. Does it have an effect on Y? It does. So if you change C, what does it do to the Y? Look at Y. Look at the Y value. Is it changing? No. Yeah. Okay, answer the question. Okay. The vertex is 1, 4. Then X minus 1 squared plus 4. Yeah. So you see this? So that is the vertex form. Using the vertex, it's hard to do if you don't know the vertex form, because we were doing the standard form. Remember I told you there's 3 forms? So this is the vertex form, and I can plug the vertex right into this vertex form, and there's my vertex, right? So I'm going to show you, I cannot do it from the computer here. So I'm going to show you get the standard form from that equation, okay? So the way you get the standard form from this is find a way to write this down. Everybody. No, stop explaining all that and try to figure out what's X times that. You only have like 50-50 chance to get it right. So it's X squared. Okay, so it's X times -1. What's X times -1? Negative X. You see, they frustrated me. And then the same thing, right? You do the same thing. This one times this one, so it's minus X again. That's what you said. Okay, so let's add them all up. X squared minus 2X plus 5. That would be the same version. You see? That's what you right? Write it all down. Yeah, because I want to be healthier. So I just like doing quadratic functions. Why? So now it says write an equation for a parabola that opens down with a vertex of 1, 4. So now they want you to actually So it said come up with an equation where the vertex is 1, 4. So for the one we just did, what did I get? X squared. So A is 1, B is -2, right? And C is 5. Do you see that? There's the equation right there at the bottom. I just changed the value. So change them. Press current. Number 4. Minus 2 plus 5. Okay. So now they're saying flip it upside down and still make the vertex the same. So now how do I make this go upside down? What do I need to change to make it upside down? Well, it has to have the same vertex like 1, 4. So you see that needs to be 4. 1, 4. Okay, so what's your equation? So do exactly what it did and then write the equation down. So everybody has their equation, right? Okay. So it says 15, write an equation for the parabola. Explain how you got your answer.